of data modeling are we talking about? And by the way, my name is Ike Ellis, and you are at the San Diego Power BI user group, and we're going to talk about data modeling for Power BI, for the Power BI professional. Just to tell you a little bit about myself real quick, I've been a Microsoft MVP since 2011. I've written several books. I speak at conferences. I'm the founder or co-founder of several user groups. One of my user groups, the San Diego Data Engineering Meetup, is meeting tomorrow at ServiceNow. And we're going to speak about DBT. I don't know if you've heard of DBT before, but it's basically a way of defining your data models and defining their dependencies so that you can build data pipelines automatically. So if you've ever had to do that manually, it's very, very difficult. You end up with a spider web of dependencies. But DBT kind of streamlines the definition of your data models and where the data is coming from, and then it builds the data pipelines for you. So it's a pretty interesting technology, and it's very, very popular right now. So we're meeting tomorrow at 5 at ServiceNow, and you can find those details at meetup.com if you want to go. Yep. Okay. So we're going to talk a little bit about data platforms and data modeling. And Benjamin, who's sitting in the room, just said, what kind of data modeling are we talking about? Well, in a transactional application, data modeling is following, usually, if you're doing a relational data modeling, it's following the rules of E.F. Codd. E.F. Codd made these rules in the 70s called data normalization. And he defined it as first, second, and third normal form. And that transactional data modeling has weird priorities. The first priority it has is it really doesn't want you to repeat any data. So any single piece of data can only be stored one time. And then the second rule is that every single column in a table needs to be related specifically to that table. You can't have any weird aggregate columns stored in a table. So a good example of a weird aggregate column for E.F. Codd would be, imagine if you have a customers table and you have a column for JSON for the last 3 orders, right? E.F. Codd would say that's awful because one, you're repeating data, probably that column has data in it from the orders table. And two, that column is not directly related to the customer. So those are, in a nutshell, the rules of data normalization for transactional applications. All of those rules are thrown out in analytical data modeling, which is what we're going to talk about. Tim, can you go down and get the pizza from Papa John's if they're downstairs?
In the lobby?
In the lobby, yeah.
If he needs help, I can go with him.
I think he's fine. Someone's coming down to get the pizza.
Okay, thank you.
All right, thanks. Yeah. Okay. All right. In analytical data modeling, we repeat data all the time. And the reason why we repeat data is because we're trying to make it very, very simple to use. That's the number one reason why we have very few tables in analytical data modeling. So that's what this topic is about. It's about what types of tables we build in analytical data modeling. And it's about how to make data models that are actually usable, that people will actually explore and use and work with. Now, the reason for this topic is there's been a lot of white noise from various vendors saying you don't need to build analytical data models anymore. And the reason why the vendors are saying this is because building data models, it's time consuming. It takes a long time, and that's expensive. And so when organizations want their reports, when they go to the data engineers and they say, please build these 10 reports for us, the data engineers say, well, hang on, it takes a second because we have to build the data models. And data models require us to think things through. They require some planning. They require some effort. And all the business leader hears is time and money and failure and risk and not fun, right? So in organizations like, well, I won't name them, but there's many of them, when they go to the customers and they say, if you buy our product, you won't need to build data models anymore. It's kind of an easy sell, right? Because they'll say, give us the money, give us the vendor the money, and you can build all of your reporting and it'll be really fast and easy, and you can skip the data modeling step. And there are many, many vendors that sell this to their customers. And these vendors are crazy successful. They're selling this left, right, and center. Anyway, I'm worried that, hang on. Hey, this is Ike.
What's up, Mike? So I got someone right here for a pizza, right?
Yeah, Tim, my colleague Tim is walking down to get it.
Okay.
And he might need to be led up to the elevator again.
Okay. There's also.
Oh yeah, if you could let them up the elevator. Yeah, please let them up.
Okay.
All right. Thank you. Appreciate it. Yeah, bye. Okay. Security's calling. All right. So the reason for this talk is because those vendors are absolutely wrong. Like, just because you buy products from Snowflake or Tableau or Click or whatever vendor says maybe data modeling is not valuable, you will regret not building a data model. And there's a variety of reasons why. I'm going to skip ahead just a little bit. We'll come back to these slides in just a second, because I want to tell you why. Actually, I'm going to show you. Let's go into Azure real quick. Okay, I'm going to go into the Azure portal, and I'm going to look at a transactional data store. Okay. Let's take a look at, I think I've got a SQL database real quick. There, this one, great. Okay. And then let's go to the query editor. Let's log in. Come on in. Hi. Uh-oh. Have a seat. My name's Ike.
Nice to meet you.
Nice to meet you. Hi,
Anya.
Colby. Hi, Anya. Yep. I think Tim's sitting there, but you guys can sit here if you'd like. Yeah. Okay, perfect. All right. Perfect. Okay. So most of your data sources will have a data model that looks like this. And this is a very simple one. So I don't know if you can read that from there, but you can see there's a product table and there's a product description table, and there's some category tables and work order tables and vendor tables, right? So this is a transactional model, and its purpose, like I said earlier, is to not repeat data. Well, if you have a ton of data and you don't want to repeat it, what that does is it explodes your table count, which is why most data sources, most software developer projects, they have 100 tables, 200 tables, 300 tables. And that table count makes the data very, very difficult to use. And it makes the data very difficult to answer very simple questions. So if I wanted a product list and all of their categories and the last company to buy it, right, I might have to join 10 or 12 or 20 tables in order to get a very simple report out of this as a source. So what we're seeing increasingly with a lot of data vendors is people are ingesting data from all of their different software applications, and their table count explodes. They'll have 100, 200, thousands of tables. And when you have thousands of tables, it makes the data very cumbersome to work with. So the purpose of an analytical data model, and I'll show you this here. Let me show you in Workspace. Let's look at a data mart tables, okay, is to have as few tables as possible. So you can see this table list down here. I don't know if you can see this here, but there's dim customers, dim date, dim products, and fact sales. There's just 4 tables there. And I can just query this, and you can see here's one fact table, and the results will come back pretty quickly. Okay. So in an analytical data model, what you really want is about 12 tables, no more than 20. You really don't want more than as few as you possibly can get away with. And the reason why you want a few tables in a model like this is because it's easy to discover. Like if you wanted to know product information, you can open up the columns and you can see here's product ID, product name, and category name. If this were a transactional system, this might be 3 different tables right off the bat. But in an analytical system, we tend to combine data for simplicity. So if you remember nothing else about this lecture, but you remember that one thing, it's that if you want to create an analytical data model that is used by other people, keep the table count as low as you possibly can. Make it as distilled and simple as you can possibly make it. What people often do, and probably the most common mistake when creating an analytical data model, is they go for comprehensiveness. They try to think about every single situation people would ever possibly want to analyze, and they try to bring in every single data element into the data model so that you got one place to go for all of your analytic needs. And that goal of comprehensiveness will make the data model unusable and too complicated, and it will sit largely idle. So this problem stems from a tradition in analytics called data warehousing. And when you think about the word data warehouse, you think about this very large room that has everything, like a Walmart or something, right? And you go into the warehouse and you find the data that you're looking for, right? And so when they build analytical data models like a warehouse, they try to make this very large thing where you can go, and if you want to build a report off of it, you'll find the data you're looking for in there. Well, I don't like the word data warehouse. I've never liked that word data warehouse, because data warehousing, even the word, sets you up for failure, right? Like there is no one place you're going to go for all of your data. And it's not going to be organized like a warehouse where there's shelves and rows and neatly structured where you can always find something. That many people tried to build data warehouses that were comprehensive, and almost everybody failed at it. They did not succeed doing what they intended to do. So the word that I prefer to use is a purposed data model. Purposed data model means I'm going to build a data model that has a very specific purpose. And if you share that purpose, you can go into that data model and you can use it for the same reasons I'm using it for. But a purposed data model, those words make you feel like it's focused, like it's not trying to be all things to all people. It's not trying to be a one-stop place for all of your data. It's trying to be something that has a very specific intention, and that intention can be documented, and that intention can be argued. And what I mean by argued is, if I tell you I'm going to build a sales purpose data set, and it's for sales analytics, right? You would expect that in a sales analytics data set, you would have inventory data, you would have customer data, you would have shipping data, right? You'd expect that. You might have a salesperson list, right? If somebody came in and said, oh, you know what? We also want HR data. Like, no. The HR data doesn't go in the sales data set, right? That goes into another data set. We might tie them in later, but I'm not going to pollute my very specific data model with data that is not aligning with its intended goals and purpose, right? Okay. So all of that roundabout way of saying the reason why we do analytical data modeling is to make the data simple to use. We distill it so that it's very, very easy to build reporting and analytics off of it. And like I said, if you don't remember anything else, remember this. The easier you make the data model to use, the easier you will make the reporting built off of it. So if you've got, like, let's say you say, I think this set of reports is going to take me a week. If you spend the first 3 or 4 days making a very good data model, you can build the suite of reports in a day. Like, you can spend your last day building reports. If you try to build the reports without building a data model, then you're going to find that you're going to repeat the same mistakes, and you're going to have to like change in the reporting, and the report authoring will just keep getting bumped out, and you'll go past that initial week that you allowed yourself. So spend time creating a very simple, very easy data model, and the reports will write themselves later. Okay. All right. Let's go back to the slides. Okay. So I'll come back to this, I promise. Yep. All right. So what tables should we build in an analytical data model? Well, there are basically 2 types of tables that we build. We either build fact tables or we build dimension tables. So if you go back to Azure Synapse Analytics, you'll see that I've built a data model with 4 tables. 3 of them are dimension tables and 1 is a fact table. And I just prefix the table names with either dim underscore or fact underscore. Okay. So if I go back to the slides, that is what you're seeing here in this little diagram here. You're seeing a center table, that's a fact table, and you're seeing these outline tables on the edge be dimension tables. And if you squint at this diagram, it kind of looks a little bit like a star. And that's where the term star schema came from, which is a center table with helping lookup tables all around it. That's a star schema, okay? So the dimensions are the points in the star, and the fact table is the center of the star. All right. Have you guys seen this type of star schema before? Have you built it or done anything like this before? No, you haven't seen this. Okay. All right. The reason why we build star schemas and we want them stored someplace, what I'm showing you is a star schema stored in Synapse Analytics, but you could build this in Snowflake. You could build this in SQL Server, right? You could build this in Databricks. You could build it in Hadoop or in Netezza. There's a million products that you could build these star schemas in. What you should not do is try to build the star schemas in Power BI. That is what you should not do. So that's an interesting thing. Because you don't know what a star schema is, I'm going to teach it to you. But let me tell you the problem with Power BI data modeling. So if I go into Power Query, I could build a data model that is so big that I have difficulty scrolling in Power Query when I look for all the tables that are in there, right? And how many of you use Power Query in Power BI? Only one of you. So are you guys new in Power BI?
Yes.
Oh, you're very new. Okay. All right. Have you used Power BI before at all? Like, have you opened it and played around with it?
I work with business intelligence, but not with Power BI.
Not with Power BI. Okay. All right. Great. Okay. So Power BI has a tool called Power Query where we can do data modeling. And Microsoft is, in my opinion, a little bit guilty of the same thing I told you that the other vendors were guilty of, which is they're not emphasizing to the users the proper way to make data models. And so what Power BI will teach you is they'll say, go get SAP data, go get CRM data, go get accounting data, go get website data and CSVs and Excel, and bring them all into Power BI, and you can report all of it once it's all into Power BI. And what that does is it builds data models with tons and tons of tables in it, and tons of relationships and tons of data. And the problem with doing that is it's very easy to get the data into Power BI, but it's very difficult to maintain it over time as the months and years go on. So what you could do is you could go get the SAP data, you could go get the CRM data, you could go get the Excel data, and when you bring it all in, you can kind of understand it while you're building it. But if you put it on the shelf and you come back a couple months later, it's very difficult to understand what you did and why you did it. And the reason why it's difficult is because Power Query, the Power BI data tool that I'm telling you about, it doesn't really use code. Instead, what it does is have a graphical kind of Excel-like expression language for combining data together. And it because of that graphical method, that's a little bit, it's just very vendor specific. You don't have a lot of developer tools at your disposal, like effective source control, like diffing and merging, like change management, like history, like those things are very, very difficult to do. So even though it's possible, I can put my Power Query data model into GitHub or into OneDrive or into a source control system. If I version it and I want to see what changed in the data model, I don't have a method of using a diff tool to see what changed in it, right? It doesn't show me, hey, this table changed names or this expression changed over time, right? So what that means is, let's say that I've got a data model in Power BI and 6 months later I go to change it again, I could mess the whole thing up, and I really don't have a great method at reverting my changes back or even understanding what changes broke everything. That's all lost to me. So what I'm telling you to do in Power BI is don't do your data modeling there. It's not a great place to do it. Instead, you should do it in SQL Server or Azure SQL Database or in Synapse Analytics or in Databricks or in Snowflake. Do it someplace else, because if you do it someplace else, when you do your data modeling, you'll be using a language. You'll be using SQL as a language, which is not my favorite, or you'll be using Python, which is my favorite, or you'll be using any other language, right? But those languages lend themselves to using source control and unit tests and other engineering methods of controlling the data structure that you do get all those positive things. You get history, you get blame, right? So imagine if all of us are working on the same data model and Andre makes a mistake, I can see it. Everything that Andre does is attached to his name. And I can say, oh, he renamed something that broke 3 things. Hey, why did you do that? And he said, well, my intention was to do this. And we can either keep moving down the direction Andre wanted to go down, or we can roll it back and get everything working again, right? All of those things are very, very difficult to do in Power BI. Yeah.
I don't know if you're going to wrap back into it, but how does this relate back to that star schema and Power BI? Because I think you made a claim that like using the star schema in Power BI is not a great data model for Power BI. Did I lose track of that, or
you didn't lose track of that? I did say that. So you're not I'm not gonna. My intention wasn't to show you guys Power Query because this wasn't meant to be a Power Query class. But let me just show you the interface real quick.
Or is it something more implicit if we have?
No. Yeah, let me. It might make more sense if I just show you.
I think you're saying don't develop a Power or a star schema in Power BI.
That's what I'm saying.
Okay,
Use,
you still encourage analysts to still use them,
yeah,
but okay,
Exactly.
that's where it wraps back in. That's all I was looking at.
Exactly.
Like,
Okay.
Making sure I understand.
So this is Power. This is the interface of Power Query, right? And I'm telling you, you have to use a star schema. You have to do it. It's the only way to build reports that are maintainable, easy to use, easy to understand over time. What I'm telling you not to do is don't build the star schema and the Power BI tooling. So if you look at the Power BI tooling, you can see things like merge queries, merge two tables. You can do things like append two tables together, that's unioning them together. You can split columns into multiple columns. You can merge columns into columns. And as you do this in Power Query, you build these data models that are complicated over time, very, very complicated over time. So you can see many people make this mistake. They take 300 tables, and what do they do in Power Query? They simplify them down to 12. That's what I began by telling you, that is a good thing, right? You want to take these 300 tables and bring them down to 12. You just don't want to do it here, because if you do it here, when you go to change it, everything falls apart and you don't know what you broke. And it makes it so that you're very reluctant to change things. Like, you don't want to change the data model because every time you do, you break something and you don't understand the ramifications of every change, right? So instead of doing it here, what I think you should do, and let me get rid of these bad tabs that we have. Hey man, get out of here.
You got a chat.
Oh yeah, I can look it up in just a second. I recommend that you do it in a more professional product like Azure Synapse Analytics or Azure Databricks or Snowflake. Any of those products, that when the data model's there, you will be able to maintain it over time, and you'll be able to see how it changed over time, which is really, really important. Okay, did that answer your question?
Yeah. No, I think
Tim got it. All right.
You and Tim, I got the full picture.
Okay, great.
Just making sure I did. I'm glad I got that clarification, or I would have gotten the wrong idea.
Right.
Thank you.
So let's go back to what a star schema is. All right. And by the way, even though you might not know what a star schema is, if you've done any analytics in any tool before, you probably built one. You just didn't know you were building one. Like, how many times have you opened up an Excel workbook and you saw a whole bunch of records in one tab, and in another tab, you saw a lookup tab where they were doing VLOOKUPs over to it. And then you saw 4 or 5 more VLOOKUP tabs. And then at the end, you saw a pivot table where they could go and drag what they wanted in the pivot table and see all the aggregations and summarizations. Business people, business leaders build that stuff all the time, but they don't know that they're building a star schema. But that's exactly what they're building, is a star schema. They just don't know data modeling. And they do make a lot of mistakes because they don't know it, but that's what they're doing. All right. So when we build a table structure that's a star schema, we have the center table or tables. You can have more than one that are called the fact table. And we have the outline tables that are dimensions. What data goes into the fact and what data goes into the dimensions? Well, all the numbers and math go into the fact table, and all the words and descriptions go into the dimension table. That's a very simple way of understanding how to model data for analytics. So in a fact table, let's say that I wanted to study sales by salesperson. The sale, the date, the amount, the quantity, the tax rate, all of the numbers that I would want to do math on, they go into the fact table. And if I wanted salesperson, sales, location, salesperson's address, salesperson's job title, salesperson's manager's name. Those are all words. Those would all go into the dimension table, into the salesperson table, okay? So if somebody told me I wanted profit by product line, the profit, the number would go into a fact table. All the product line information, all the descriptions of the product, the category, the when it was made, or when it was commissioned, or who made it, or what the product number was, or the ISBN, or anything like that, that would go in the product line table, right? A very common dimension that's an outlying table is date and time, because in almost all analytics, we want to know what day, month, or year it happened. We want to compare it to the last month or to 13 months ago. Compare March 2023 with March 2022, right? Even though dates are numbers, if you break the dates apart and you have like day of the week and the month name and things like that, that breaks apart into a dimension table. So we put date and time as a dimension table. It's in almost every single star schema. All right, let's look at the chat question. They said, what screen view are you looking at in Power Query? I wasn't, I just picked up probably an old screenshot off online because I didn't want to open up Power BI. Okay. All right. All right, any questions about that so far? Nope. Okay. So this is a very specific star schema. This one is built very similar to like the Northwind database. And you can see the middle table, the column names for fact orders are like order number, line item number, quantity, revenue, cost, product. That's all numbers, right? In addition to those numbers, we also have keys. These keys are relating to the dimension table. So the customer key here is related to the DIM customer key. That's how we're building the relationship between the tables. The salesperson key is related to this salesperson key here. Product key is related to this product key, okay? And then if we want customer information, here's customer name, the city they're in, the region they're in, whether or not they're a premium customer or a regular customer, a retail customer or an internet customer, all of that stuff will be in the customer table. And then for salesperson, their name, the store they're at, the city they're at, the region they're in, for the salesperson would all be here. And by using a data model like this, I can answer any question related specifically to sales, right? If you can think of the question for sales, I can answer it in a data model just like this, right? So if I said, I want to know the profit for March, I can answer what the profit for March was, right? I want to know our total revenue by salesperson, I can answer that, right? I can build the report off of this data model, right? I want to know who my biggest customer is, right? I can answer who my biggest customer is off a star schema. And I can do it so simply that if the sales director said, hey, I read a book about SQL and I want to understand more about my sales data, I can open up this purpose data model to the director of sales and I can let her, do all of her own analytics on it. And if she does a quick little Power BI class, she can build Power BI reports herself off of that data model. Yeah.
Yeah, I feel like I have a good question to insert here. What about partitioning and sharding? Specifically around like, I'm thinking in this particular topic, what if it's a very large amount of data and you have multiple regions? How do you kind of fold that into this where maybe these 6 tables would either grow too big or too much in complexity, right? Like especially with larger data sets, you are going to eventually have to cross that with your data model. Some sort of thinking about how do I have consistency and speed, right? Especially with larger data sets.
Right. I promise I'll get to that in just a second. Yeah, I will. All right. Okay. So let's look at building.
I have a question. So do you, when you're building this, in some tool and then you're going to consume it in Power Query, do you build a view that does all the joins for you, or do you join it up in Power Query?
That is one way. You don't join it up in Power Query. No. Oh, I'm sorry. Are you saying, let me see if I understand this.
So I'm going to connect to this database right here, this star schema. And is it going to have a view that has all the joins all done for me, or
No,
or
nope.
you join it up
You-
in Power Query?
No, that's an excellent question, actually. You want Power Query to do the joining. And the reason why you want Power Query to do the joining is because Power Query will actually be faster at its job if you let it do the joining. So if you go through a view, then a bunch of things might not be as quick in Power Query. So let Power Query do that work for you. And when you go into if I went into your Power Query and all I saw where it was joins to these tables, I'd be so happy. Like that would be a very simple Power Query data model, which is exactly what we're going for. Yep.
Is that because of the power of query folding that?
Yep. Part of it is query folding. That's true. Yep. Yep. But part of it is like Power Query or Power BI doesn't actually issue any type of analytics until the visualization is displayed. And so it knows that it can avoid some of these tables if the visualization isn't using it.
Right.
So you want to let it go ahead and avoid it, right? If it says, oh, that dim salesperson table is huge, and this visualization isn't using any sales data, I'm not going to use it. I'm just going to use the other tables, and it'll be much, much faster. Yeah, thanks. Good question. All right. Okay, so first we're going to build a dimension table. So dimension tables are denormalized. So if you remember when I talked about EF-COD, I said the rules of data normalization is that we don't repeat any data, right? Denormalization is a fancy word of saying we repeat data all the time. We repeat all the data all the time. So what do I mean by repeating data? Well, do you see this store name? Let's say that I have 100 salespeople and 5 stores. That store name is going to get repeated. So if I have a store called the Broadway Gas Lamp Store, right? The Broadway Gas Lamp Store is going to be repeated for every salesperson that works at that store. And if there are hundreds over time, they're all going to get that. You're going to get that name hundreds of times. If that store name were to ever change, I would have to go and change it on every record in that table, which might seem a little counterintuitive, but it is exactly what you should do. You absolutely should do that. And the reason why is we're repeating data to simplify it. So if anybody wants any information related to the salesperson, they go to one table and all the information's there. There might be 100 columns here, maybe 200, but there might be a lot of repeated data there. And that's perfectly okay. We would rather have the repetition and know that if there was a mistake, we'd have to correct it in the table than have 15 tables that no one really understands, right? Okay. Dimension tables are usually wide. Wide means lots of columns. So right here, you're only seeing 7 columns.
Sorry.
No, go ahead, Tim. No.
I was thinking back, but I see your slide clearly says.
Dimension, yeah. So dimension tables are usually wide. So dimension tables have lots of columns. So if there's a column that you think you're going to want to report off of related to salespeople, you're going to want that column in the dim salesperson table. Duplicated values are preferable to joins. We don't want to join. Now, here's a rule for dimension tables. When you build your analytical model, use what's called a surrogate key. A surrogate key uniquely identifies that row in that table that you build, you make it up. It's a made up key. You made it up. So it could be integer, like 1 through 1 million, right? It could be a GUID. It could be whatever you want it to be. It should be numeric though. And it should be a key that you make up. there might be a temptation to use employee number. Do you see that key here? That's called a business key. That employee number came from the source system. So whatever salesperson ID came from the transactional application, right? We are not going to use that when we build our joins. So if we go back to our star schema here, this key is one you make, not one that you pulled from the source system. And why is that? Well, I'm glad you asked, Ike. The reason why is because business keys change. The business might modify it. They might get acquired. They might change source systems. For whatever reason, those business keys might change over time. And you don't want your data model built on something that's going to change over time. So make up your own called the surrogate key, but it's okay to use the business key. So what's a good example of that? Well, if I go back to Synapse Analytics and I go to DIM customers, this customer ID down here is a surrogate key that I invented, that I'm using for all of my joins. And actually, I don't see a business key in here. I didn't bring.
How do you associate the two? How do you associate that customer record that you're getting from somewhere to your surrogate key?
Well, you just make it up. So let me show you. And by the way, do you guys want to take a couple minute break?
Here is a restroom.
Um,
To the left, the restroom.
yeah.
So this is John. Question.
Sorry.
So I do a lot of work.
Okay, everybody's circling then. All right.
Can you hear me, guys?
Yeah, I can hear you.
So I do a lot of work with, kind of with business teams and kind of a shadow IT role. I don't have access in some cases to database tools. So I do end up doing a lot of my joining off of, flat files. I'll do extracts out of their systems, create dimension tables, and then join my stuff up off of those flat files or Excel files, and I'll create master data tables, and I'll, do all my joining in Power Query. Is there some alternative for somebody like myself where I don't have access to those other tools to do something that's more efficient, or a better way of going about it?
That's an excellent question. So I would, I can tell you what other leaders have done or other analysts have done. Okay. So I'm going to repeat your question so people in the room can hear it.
Okay.
So you guys, we had a question online. Okay. And he said, he doesn't have access to professional tools to build data models. So he has to do it in Power Query because at his company, he doesn't have access to it, right? So one thing that people have done is they've basically installed their own database and done their work in their own database. So they've installed it either on a laptop or a machine somewhere, and they brought the data in so that they could work with it in their own database. And then the problem with that is the refresh is difficult because Power BI, you can't deploy it to the Power BI service and refresh it off of your laptop unless you install the Power BI data gateway. And people have done that. So that data gateway, you would also install on your laptop and you would point it to the database on your own machine that you do all your data modeling in. And then the Power BI service, the app online, can reach down into your laptop and pull the data and keep the data fresh so that you don't have to keep extracting the data, building it, and redeploying every day, or every month, or what interval you're using, so that the data stays current. Does that make sense?
Yeah, it does, but the problem is that I build these tools and then I go away, and then the end users who don't have those kinds of skill sets, so basically they do all the extracts out of the source systems, get the flat files, they drop them in folders, um, and they become self-sufficient. They don't really know what's going on behind the scenes or how to use Power Query, and then I roll off, I go away. So I found
Yeah.
myself kind of in a bit of a dilemma where it's like I basically just have to do everything in Power Query with I use other reporting tools to get really wide data fact tables. But then it ends up being either CSVs or Excel files.
Yeah, so what I would be inclined to do is do more modeling in the CSVs. Like I would be more inclined to make the CSVs cleaner.
Yeah.
So that you were doing less in Power BI.
Right. And that's what I'll do is I'll use the enterprise tools, the self-service reporting systems that we have to create really robust fact tables or dimension tables.
So somebody asked, how would you create a surrogate key when you were building a fact table or something like that, right? Well, what I can do, and I'm not showing it here as an example, but like this is a very simple surrogate key, right? Like this is me just creating a row number. And if I load things in the right order, let's say that I wipe out the data model and I rebuild it every night, right? I would build all my dimensions first. And I would, this would be as fact sales ID, right? Something like that. Okay. So I would build all my dimensions first. I'd build a surrogate key using like the row number function, like here. And then when I built my fact table, I would have my fact table look up the right row in the dimension, pull the surrogate key into the fact table. So that's a very simple example. If I were going to rebuild this thing every night, that's what I would do, right? But that's one way of doing it. There's probably 10 different ways of building surrogate keys. Okay, does that make sense? Here's another example, by the way. If I go into my date dimension, now date is the one dimension that I probably wouldn't build a surrogate key for, because we know that the date isn't going to change. So if I would decide what format I wanted my dates in, and I would use that format everywhere. I wouldn't vary from it. So I prefer year, month, day. So basically more broad to more specific. And then I would use that format in every place. And then you don't really need to build an explicit relationship, right? But look at what my date table does. It says, here's a day. Now this is kind of, interesting code a little bit, right? What this does is it iterates through every day from January 1st, 2000 to December 31st, 2050. And it takes the individual day and it breaks the day, month number, year, month number, month name, quarter number, quarter name apart, so that it makes the querying of my data very, very simple, right? And let me show you the end result of that. So if I go into my data and I look at dim date, you can see all of those columns broken apart here. And if I show you the actual data, we run it. Sometimes Synapse is not the fastest sometimes. But you can see how it's broken apart, right? Here's October, here is, let's see if we can see. That's day is the day of the month. Hey, scroll over. There we go. So, what I'm surprised I don't have is the actual day of the week. I would have thought I had that. That's weird that I don't. But But you could see like this quarter name, Q4 2012, right? Or you see this quarter name, right? What's interesting about the quarter name is this. I'm going to write a query. There we go. Here's a query. Select sum total sales from fact sales FS join date D on FS dot date sale date equals D dot date, right? Now here's the where clause, where quarter name equals Q4 2012. Okay. It couldn't be simpler. If somebody asked me, I want to know our total sales for the fourth quarter of 2012, I can pull that in 5 lines of code. If I had to figure out all the dates that existed between October 1st and December 31st, 2012, like that query gets a lot more complicated to write. So the reason why we're breaking the date apart into all these different columns is if I wanted to know the total sales for every Monday in May 2023, I can say, join the dates, but only give it to me where day name equals Monday, where the month is May and the year is 2023. And now I'm only getting the sales for those specific dates, as opposed to try to figure out what dates are the Mondays, right?
Would you also add in the fact that as you're onboarding or as the team grows, that having good data models like this help effectively communicate intention
Absolutely.
and appropriate language? Because that is a really awesome example of things that I've definitely seen tons of people do in their own queries, or at the output phase, whenever they're querying the data, creating their reports, and it kind of obfuscates shared knowledge, which, whether it's onboarding new teammates or watching a project or a team evolve, by data modeling, you're actually encapsulating that knowledge. So again, if you left, or if even the analyst left, it's like there's just like that shared knowledge. If you have anything, I just want to make sure
that kind of goes back to the earlier thing I was talking about a purpose data set, because the simpler you can make the data set, the easier the onboarding to that data set. So if you keep your data sets distilled and easy to read and easy to understand, then not only does it increase adoption from the business people, but as more data engineers join the team, they can immediately begin working on it. The problem when we make data models that are too huge is it takes months to understand it before you're willing to touch it, right? You don't want to change it because you're not sure your brain has all of the ramifications of changing it in there yet. So you just spend months learning before you're willing to dive in. But if it's a smaller and easier to understand, even if it's a ton of data, even if it's gigs and terabytes of data, you're far more likely to be brave and add value to the team. Okay.
Before you move on, can I ask a question?
Sure.
Okay, thank you. So, and it goes back a little, to what we were talking about right before this. If you're going to have to do a lot of flat files, and you brought up the concept of master data and not building data models, doing all of the heavy lifting inside the Power Query, where does your master data dwell at? Can that dwell in Power Query, or does that have to fall outside of that toward, whatever source structure you're using?
I prefer it to be in the source structure. And I'm going to show you one way to build it in just a second.
Thank you.
Okay. All right.
May I ask you?
Yeah,
question?
sure,
Can you
Michael.
build the query which you wrote?
Sure.
And what I want to ask you is that the where condition is not it more convenient to include it in join condition, because
No.
no?
Nope. You want to be very specific when what you're joining by and what you're filtering by, because you want to lead the data products optimizer to make good decisions when it creates its physical execution plan. Okay. So when you try to tell the optimizer exactly how to join, what you're doing is you're hurting the flexibility of the optimizer to make its own good decisions. And these optimizers are written by some of the best data minds in the world. So a mistake people tend to make is they tend to be too comprehensive in their querying. They're too instructive. And when you're too instructive, you're not telling the optimizer something better to do. You're actually constraining the optimizer, right? And constraining the optimizer means that if the data changes distribution, it changes density patterns, it changes any of the physical elements of the data, the optimizer doesn't have room to maneuver. It's just going to be stuck in your structured way of pulling the data back. And that's a very bad thing and leads to performance problems. Yep. So use the clauses for their intended purpose. If you're filtering, use where. If you're joining, use join. Don't conflate the two. Okay. All right. Good question, though. All right. So that's dimensions. All right, let's talk about fact tables. So remember, facts are where we have numbers. Facts are filled with measures. So these numbers can be additive or non-additive, right? So an additive number might be cost or profit. Non-additive might be margin, right? Because we don't add percentages, right? We don't get anything valuable when we do that, right? They could be semi-additive, like account balance, right? So maybe account balance is semi-additive if it's rolling, but if it's a snapshot at the end of the month, you wouldn't necessarily want to add that, right? That's not valuable. So yeah, all the numbers go in the fact tables, and that you'll see either dates, numbers, or keys. If you see any text, it's probably misplaced. Not always. An example of text that might be in the fact table that isn't mathematically valuable, but we might want to put it in the fact table would be like tracking number, right? So if for whatever reason people want to see the UPS tracking number in the order, we can put it in the fact table because you'd never want to build a dimension off of tracking numbers. It'd be 1-to-1, right? And there'd be a billion records there, right? Okay. All right. And that's the fact table. Now, the most important thing you can do when you build a fact table is choose the grain of it. That is by far the most important thing you do. So what do I mean by grain? Well, if we're selling RVs and every RV is $200,000, the grain of the fact table will be each sale, right? Because how many RVs am I selling a month? 1,000, right? So the fact table is not going to be very big, right? If I have 1,000 RV sales all lined up in a row, big deal. If I've got 10 years of that, I've got tens of thousands of records. I don't have billions and billions of records, right? Okay. So in the RV sales, the grain is the individual sale. Every time I sell an RV, there's a record in that table. Okay. If I'm selling hamburgers, I do not want the individual sales record because I'm probably selling hundreds an hour over lunchtime, thousands a day. And if I've got 100 stores or 1,000 stores, now I'm ballooning up that fact table to be unusable. And analytically, I probably don't care about the sale of an individual burger. That's not interesting to me. But what is interesting to me is compare my lunchtime sales for my San Diego store versus my LA store. That's interesting. So what grain should I use? Probably hourly. So I would have in my fact table for May 16th at noon, the San Diego store sold 40 cheeseburgers, 200 chicken nuggets, 100 order of fries, and 20 Diet Cokes, right? So each one of those columns would be added up, that hourly sale, so that I could analytically compare that to day over day or weekend versus weekday or Mondays versus Fridays or 2022 versus 2023 or this store versus that store. But if I went to the individual sales record, I would have way too many records and I'd be making Power BI do way too much math when it had to do its aggregations, right? So The number one thing we choose when building fact tables is we choose the appropriate grain of it. That needs to be a deliberate decision. Okay. So the reason why we make star schemas, they're easy to use and easy to understand. They're one version of the truth. They're easy to create aggregations. It leads to faster queries. And they are also supported by all the business intelligence tools like Excel, Power BI, Tableau, Click, everything. So what I always say is you can either start out by making a star schema, or you can one day wish you did. Those are the only two choices. Okay. So to answer Benjamin's question, Benjamin said, what about partitioning? And that is a very good question. So let me go back to Synapse real quick. And again, this is the tool that I'm using to show you my star schema. Okay. But you could use SQL, you could use Snowflake, you can use Netezza or Vertica or Redshift, that's AWS Redshift, or GCP BigQuery. You can use any tool you want. I'm just using Azure Synapse to show you. Most of the tools that most of the things I'm about to show you are true for every tool, okay? All right. So this looks like, how many of you have written SQL before? Okay, written SQL, okay. And you've written the SQL over a table, right? This looks like a table, right? Okay. So does this look like SQL Server to you? It's kind of looking like it's SQL Server. It is not SQL Server, okay? What this is a file-based data structure. So in my data lake, which we haven't really talked about, but that's beyond the scope of this, I have a bunch of folders. And in one of those folders is the data mart folder. And in there, I have the sales database. And there I have 4 folders: dim customers, dim date, dim products, fact sales. You've seen those before, right? We've been working with them all day today, right? So if I go into dim customers, what I'm seeing in here is something called a Parquet file. That is a file on a disk, just like a CSV or an Excel file. It's a Parquet file. I built this file using a data pipeline, which is beyond the scope of this, but just understand that this is a file. That's all you need to know, okay? If I right-click on that file, I can query it. And what you're seeing here is a call to a file. That's the Parquet file. And you're seeing select top 100 asterisk from that file. So if I run it, look what I get. I get columns and rows with data in them, right? So if you see like Modesto in the city, I can say where city equals Modesto, and I can run it. And now I'm only getting the 2 records, the 2 customers in that Parquet file in Modesto. That's what I'm getting. Is that interesting? It's pretty neat that I can use SQL just like it was a SQL server, as if that were a table, when in reality, it's a Parquet file underneath. It's just a file. Now, why am I using files instead of using SQL Server? Well, there are a wide variety of reasons, but the number one reason why I'm using files is it's way, way cheaper. It's actually pennies on the dollar. So up to 100 times cheaper to use files than it is to use a SQL Server. And the reason why is, as data goes into a SQL Server or Oracle or Postgres or MySQL or any of the very big relational data stores, as data goes in there, if I need to iterate over the data, I need bigger and bigger CPUs. And so if I've got a table in SQL Server and there's 1 billion records in it, I need 8 or 16 CPUs. Well, SQL Server does their licensing based on CPU. So if I want to buy SQL Server Enterprise Edition and I need 16 CPUs because my data is really big, I am going to pay $7,000 per CPU to have that SQL Server. So, I've just described a $100,000 licensed server. to use that, right? That's very expensive. And that's only for 1 billion rows. Today, we do billion row things all the time. We're doing billion rows left, right, and center, right? So why do I use files? Because files don't charge me SQL Server licensing. That's why I use it. So that's where I save my money. That's the pennies on the dollar.
Ike, why a Parquet file versus just a CSV?
That is an excellent question, and I'm glad you asked that. Okay. So does everybody know the structure of a CSV, a comma delimited or comma separated file?
Yeah.
It's just a bunch of data, usually in double quotes with commas, right? Okay. And by the way, this works with CSVs. So in fact, I might have one just to show you if I wanted to use a CSV, it's right here. Let's see if I've got a CSV in here. You know what? I might have it in landing. Let's open up landing. No data in there. Let's open up AdventureWorks. No. Oh, it might be in raw. Let's look at raw. AdventureWorks, address. No, it's Parquet. I don't know that I have it to show you. I can't show you, but just to let you know, these queries, if this were a CSV, this query would work. So it doesn't have to be Parquet. You can use a CSV, put it on in your cloud storage account, and you can run SQL like normal off of it if you want. Okay, why use Parquet? Parquet files are heavily compressed. So if you had a 1 gig CSV, it would be like a 20 meg Parquet file. And when things are compressed, they're faster and cheaper. So that's, if there's no other reason to use a Parquet file, use it for that reason. It's cheaper and faster. Smaller things are faster, okay? But the second reason to use Parquet files is Parquet files maintain their data type, which means that ints are ints and dates are dates and strings are strings and decimals are decimals. CSVs do not maintain their data type. So if you try to do math off of something in a CSV and a CSV violated its data type, it would crash the query. Parquet does not allow that to happen. Once Parquet has a column defined as an int, it rejects any field that violates that data type. So those are the two big reasons. Actually, I gave you 3. They are cheaper, they are faster, and the data is cleaner in a Parquet file. Does that make sense?
Yeah. Is there any kind of indexing?
Well, that's how you get, one of the ways you get the faster is Parquet files are stored in a columnar data structure, which is very similar to a column store index in SQL Server. It's similar to a Tableau extract server. And believe it or not, it's exactly how Power Query stores its data in Power BI as a columnar data structure. So Parquet files are columnar, which make them very, very fast for one specific thing, and that's analytics. Yeah, Michael.
May I ask you, where we store these files? They are stored at servers, a file server, or where are they stored?
In Azure, they're stored in Azure Blob Storage or Azure Data Lake Store. In AWS, they're stored in S3, just the normal file storage accounts that all the cloud vendors have.
So they are stored at Azure, and we access it for our application.
Yeah, that's right.
Okay. And one more question, please. These files need to be generated, yes?
Yeah.
And when they are generated, by whom?
Yeah, well, the way I generated them, I can show you 2 different ways of generating them. This is a SQL statement that says create table. Now you've used create table before, right? But this is called a CTAS statement. So it's create table as select CTAS. And what you could see when I said create the data from this data source, I just said use Parquet, and this data, this statement built that Parquet for me automatically. That's one way to do it. Okay, here's another way. No, that's the same way. Here's another way. This is Python. In Python, I said, go get a bunch of data. That's this query. Go get a bunch of data. I'm going to change it. And then I'm going to write Parquet, overwrite it and save it as a table and call it, dim product or whatever you're going to call it. That's doing it in Python. So, yep, that's how they're built. Yep. If you want to do it in it from the source system, my source system says, go get a bunch of tables. Here are these tables. Here's the table list. Go get all those tables, iterate over them one at a time, and then do what with it? Write it out as Parquet, save it as a table. Yep. That's called a Python data pipeline. Okay. I'm going to go back to the data real quick. All right. So Benjamin asked a question, and what he said was, what happens when there's a lot of data? Can I close some of these? I can close this, right?
Yeah.
There it is. Okay. Well, I'm going to go back to Data Mart. I'm going to go back to sales. I'll go back to my fact table, right? What you're seeing here is one file, just one. But if I ran that data pipeline, that code that you just saw once a day, I could build a file every day. So if I ran that thing every day for a year, you would see 365 files here. And what's amazing about a modern data platform is it's only one table. So when I go to query fact sales, right? Fact sales can exist in 365 different files if I wanted it to. But I can treat it logically like one thing. Why is that valuable? Because when you have a lot of data, you can tell Synapse, I need a lot of compute. I've got billions of rows. I don't want to control how many servers it takes to give me that data back. I want you to control that. All I'm going to tell you is it's a lot of it, and it's in a bunch of different files. But I want to query it like it's one table. That's called partitioning or sharding. And what I'm doing is taking a lot of data, breaking it apart into smaller files, and letting Synapse decide how many servers it takes to read all of those files, right? And Synapse can say, that's a lot of data. I'm going to need 20 servers. And we'll spin up 20 servers, and it will ingest all that data, and then it will give you the results of your query for you. You'll pay for that. It'll be more expensive, but you'll only pay it when you query it. You won't pay it like SQL would make you pay it all the time, right? But this system lets you pay it only as you read it, only as you use it. And what that means is if I've got sales data every day for 10 years, I'm probably only using today or this month or maybe this year. I'm only using the hot data, and all the cold data is just sitting there, never being used, which is cheap, right? So I could have 10 years of sales data, and I don't pay anything if people don't read it. It's when they read it that I start paying for it. And that's partitioning and data modeling.
And you can also configure this process to make sure you allow only a certain number of processes, right?
Absolutely. Yep. You can say, only do it monthly. So only rebuild the last month.
No,
Right.
what I mean is like.
Oh, the number of nodes.
Exactly.
Oh, absolutely. Yep. You can control it all.
It takes a little longer, but.
There's a million ways to control costs. And there's also a million ways to not control it and get surprised. Yeah. Yeah, which has happened to most of us. Okay. So there's one other data structure in star schemas that I wanted to talk about. And let's see if I've got it here. You know what? I might have it in a different deck real quick. Let me bring up a different deck. Let's bring up this older one, because I think I might have cut the slide. Uh-oh. I don't have it, but you know what? We're kind of running out of time. But I want to point you to real quick before we go, because we're only supposed to be 90 minutes is this is my YouTube channel. And it's called, if you can see the URL here, you can get to it. It's called Ike Ellis on the Mic. And if you actually go to ikeellis.com, that's me, Ike Ellis, you can see Ike on the Mic right here. And that takes you right to it. See, oh, there, Ike Ellis on the mic right there. Okay. All right. So in here, I have some things about Power BI. And I also have data modeling things. And one of the ones I wanted to tell you about, let's see if it's in Power BI. Let's see. I think I might have done it in Synapse. Let's see. I don't see it. Where are you? You would think it would be right here because, oh, there it is. It's right here. It's just not organized. All right.
So I want to
So
explain why we need.
this is a 5-minute video. And I'm going to put it in the meeting chat. Yes, I'll share the recording on the meetup group. And I'll paste this. And this will explain, it's a 5-minute, 6-minute video on slowly changing dimensions. It's one aspect of building star schemas it's very valuable in Power BI. And if you want to, I think, it's very short, so it's not a big waste of your time. And you can use that video to learn about a very important aspect of data modeling in general. And that's it, you guys. That's our session today. Hopefully you learned a little bit about data modeling and some best practices. Any questions?
Well, I mean, I want to pick up, I think it was really awesome. We started talking about Parquet and it seemed like some people here haven't used them. And I wanted to get a shared understanding, make sure I'm correct. Parquet is known to be immutable, right? As in, like, you're not supposed to write updates. It's expensive. I think that you can, but would you want to explain that a little bit and the kind of methodology for whenever your data model changes and whenever you're using Parquet? Because if I change my data model and I'm writing a data pipeline and it's pumping out Parquet for my analytics team and that we have like the ecosystem set up, what do you think whenever like you add extra tables or you're adding more columns whenever the data model evolves, how the fact that again you're not going to go back to those Parquet files and rewrite them, right? You're gonna, like you were using that month by month example, the hot data.
Yeah. So Benjamin, just to keep in mind, most people in the room are not data engineers. They're Power BI professionals. So that's a pretty advanced topic. But effectively, for most of your data in the room, probably 90% of it, it's okay to blow the data model out and just redo it. And that's something that you would not want to do in SQL Server. So if you've built a data warehouse or done this work in SQL, SQL can get kind of slow and expensive. And so people are very reluctant to just start over and do it again, right? But in Parquet, we're actually, for smaller data sets, we're more likely to blow it all away and do it again. And the reason why is because in Synapse and Snowflake and Redshift and Aurora and EMR, the compute is scalable. So if I had to rebuild a purpose data set that was 50 gigs, in SQL Server, that might take me all night. Mm-hmm. But in Azure Synapse, that'll take about 15 minutes. So when you have a file-based data structure and you're using something that scales out easily, it's only really a question of money. It's not really a question of time. So if you want to make data modeling changes or you make a mistake, it's a 15-minute problem. And 15 minutes later, it'll be fixed. Even if it's 50 gigs of data, it's about a 15, maybe 30-minute problem. Where if you have 50 gigs of data in SQL Server and you make a mistake, you've ruined your whole week, right? You've really cost something here, right? So there are data sizes where you wouldn't want to blow it out and redo it, either because it's expensive or sometimes you might even lose access to earlier data, right? The data that you have is now important and you don't want to redo it, right? In that case, it requires better strategies at handling something called delta loading. And delta loading is beyond the scope of this session. We were focused on Power BI data modeling. If you're interested in strategies for delta loading, we can have another session or probably go to a San Diego data engineering meetup and they'll cover delta loading.
Also, the Parquet, the fact that it's compressed and you can feed more data, it gives you an option to reload from scratch and keep the old one and reconcile in fact something on the SQL server like Max, like I said, like all night. I've seen weeks in SQL server when you have to reload some tables, right? With Parquet, it's faster and it takes less space. So if you're not sure if you're building something from scratch, but you still want to keep something for reference, it's easier to do that in Parquet format. You know?
Any other questions? All right, well, thank you guys for joining us tonight. Appreciate it.
Thank you very much.
Yeah. And reach out if you have any other questions. And what I'll do is I'll post the slides and the recording and the link to that YouTube video on the meetup for you.
Personal question. So, you said that in the previous meeting, you said that in curricula, somebody wanted SQL specialist.
Yeah, I passed it on to them. I did, yeah.
How may I send to your CV again? For you said that you show it on support.
Yep, sure.
I will send it to you again.
Yep, you bet.
So how is a tool like Power BI, and even whenever I was asking that partitioning question, I wasn't necessarily trying to just dive into specifically like the sharding.
Yeah,
Even more of like looking at it at the data model level with, again, I'm just picturing an enterprise system and I have, let's say I'm a data engineer or some data architect in between, right? How do you keep the data model synced up between the consumers and the producers is kind of something I was wondering about specifically with.
that's a
Power
good
BI.
question. Yeah, there are many ways to do it.
Right.
I can give you my favorite ways. Okay, the first thing is I don't feel like old data is analytically useful. So even though organizations tend to keep old data, when they keep it, it's almost like, well, what if I need it? Like they're hoarding data, right? And I might need it one day, right? But what about business in 2018 would tell you anything about how business is going to operate in 2023, right? Pre-pandemic, pre-machine learning, like the world changes too fast. And if you need to go back into 2017 to make a decision today, you probably have bigger problems than your data. So analytically, I really see the only value being the last 18 months. And so if I have a big data warehouse with 10 years of data, I'm likely to tell Power Query, when you bring in new data, only bring in the last 18 months. And that's all they'll ever look at. That if they need more, they can call me. I'll tell them what the numbers were for May 2020 if they really care, right? So that's one way to handle it, is just filter it on ingestion, right? Another way to handle it is the engine that runs Power Query is called the Vertipack engine. And it's the same engine that runs Azure Analysis Services. It's the exact same engine. Power BI Premium and Azure Analysis Services allows you to partition the data, which means not only can you partition it in the star schema, but you can also partition it in Power Query. if you have premium or if you use Azure Analysis Services. What that means is if I've got a data model in Power Query that has a ton of data for the last 18 months, I can tell Power Query, hey, I've partitioned this monthly, which means you only need to rebuild the latest month. You don't need to rebuild the earlier months if you're trying to do any aggregations or anything like that. And that will improve speed. But when I go to refresh the data, I'm only going to refresh the last month.
And does that specific tool set, because again, I'm going to try to take off the specifically code helmet, but like upstream effects, aka, and I've had this happen with working with startups where we change something or the software engineering team changes something that literally changes some operational outcome, and the data model between never picked it up. But with like this example is that like, well, what if you actually had to update old data? Would those queries, those views, those reports be rebuilt automatically? Or do you have any thoughts with that with Power BI or data modeling and how that can be handled without just sending out emails and calling everybody or having a meeting and being like, hey, there was this important thing, we need to relook at specific reports and have to rerun them completely?
Yeah.
I hope that makes sense.
Yeah, it does. Have you worked with Parquet before?
Yes.
You have. Okay. So Parquet has this concept of graceful failure, right? So if the data model changes, and let's say they added 5 fields to it, and the last 10 years do not have those 5 fields, Parquet pretends like it did. It just nulls it out and says, NaN, that data, I don't have that data. I believe you when you say it should be there, but I didn't find it. So I'm just going to say I didn't,
I'm
it's
talking more of like, let's say that there was an actual like error where maybe there's a decimal place wrong, right? Like I've dealt with that with numerical data where it's like, is this in millions of dollars or is it in hundreds of thousands of dollars, right? Or
right.
And then you update, like the data model gets updated because it wasn't documented correctly.
You can, when you find those things, some kind of,
Yeah.
unless you break the data type, you probably won't be able to catch the difference.
Thank you.
Yep, you bet. Nice to meet you. Yep. Bye-bye.
Unless you build some data rules that, let's say, a certain column has to be in a certain range.
But then we're getting into like DB feedback, right?
Yeah.
Great expectations.
Or great expectations. I remember that.
Yeah.
Okay. Yeah.
Yeah. No, that's a process thing. That's a governance thing that, you build in when things change. What is the standard operating procedure of what has to change with it and what you double check with it?
Yeah, and it's also like from the other end, right? And that's another interesting feedback loop that I come up from listening to your talk is that creating data models, like you had that date table, certain bit of that is one experience, right? Like and then also like feedback loops and that like, having healthy governance where you're actually the people who are doing the data modeling or the people doing the analysts are technically capable enough to build the data models themselves, ideally, right? Maybe, I don't know, it depends on how you want to cut the cake. But those lessons learned, again, this millions of dollars is an example of I've had to deal with. It is like,
Yeah.
Because again, like why no one wants to read it. And if you're talking about stock level data across months, it's you don't need dollars, no one cares about down, you just need it rounded, but how you're rounding it does matter. And again, like your table example, it actually would be one way you could create if I ever correct a fact table where you have it in dollars, millions of dollars, thousands of dollars, but that domain knowledge is only found through the analyst process. You don't want to over expect what the analysts or how the analysts are going to use it, how they're going to mutate it. But eventually with a good governance, you would fold that into your data model, which would improve their queries, improve, again, back up everything that you've pointed out in your talk.
Yeah. Thanks.
It's always going to be an iterative loop. Ike and I work on a project together and you build the initial model the best you can. And until the customer says, oh, I want to do this. I want to look at it this way. I want to answer this business question. And so you might actually do some of that modeling, some slight changes in Power BI, but you're always going to want to push it back as far as you can, right? Because you're going to have better performance in a in the data source versus downstream Power BI. And if you and this is a hard lesson that I learned is the more you pollute your Power BI model, the longer your data refreshes are going to be. And there's a limit, right, at the Power BI service, depending on what license you have, on how long it's going to take to data refresh. Plus, your client may not be happy with waiting 20 minutes for your data refresh to finish. So if you can do as much work as possible upstream, it's going to be much faster for data refreshes, better performance, and finally when you're doing your Power BI visualization renderings too.
It is definitely something you want to do on the data source, not in Power BI. Catch any kind of exceptions, right? And I think Python, PySpark, they have really nice functionality there where you can you just define your exception criteria, essentially like a where clause.
And
then it just finds it.
and then filters it to the right
Yeah,
table for
exactly.
error reporting.
So what we do, we actually have a few projects where, and we want to do it more, where we route something that right off the gate goes into wallet, and then something that is question goes into quarantine. And that quarantine gets reprocessed, fixed, whatever later.
All right, you guys, I'm going to end the recording. Thanks for coming online. We'll see you next time.
Thanks, Ed.